Hi, we're going to go ahead and find the rate of change from graphs and equations. And it says, pay attention to the units. Okay, so for instance, on this very first one, on this graph, we have the number of Spirit t-shirts. And so your x-axis, they go by ones. And then over here on your y-axis, which is the cost, it's going to go by 20s. So the first thing we're going to do to find the rate of change is it says, what is the rise? So we're going to start at 20 and we're going to rise up to 40. So that gives us 20 as our rise. And then we're going to go over 1 unit, and these go by 1, so that'll be 1. So the rate of change, 20 divided by 1. So the rate of change means how much it is per 1 unit. So this is going to cost $20 per 1 t-shirt. Now then, it says, well, what do you think the $20 on the y-axis represent? Well, this is the starting amount. It's not per shirt, because if you notice, it's 0 shirts and it's $20. So if this is the starting amount and it's not the cost per shirt, that starting amount could be what it takes to draw the picture. Maybe they're charging something like that up front. But if you go ahead and set up a table of values, 1 shirt would actually cost $40, because that includes the starting amount, the setup fee, and it includes the t-shirt itself. But if you notice then, 2 shirts would cost $60. 3 shirts would cost $80. So you can see the difference here. From 40 to 60 is 20, from 60 to 80. All this is a difference of 20. So basically, it's your $20 per shirt, and it just happens to be that $20 is also the startup amount as well in this certain figure. All right, let's go ahead and look over on problem 2. Problem 2 says we're talking about lemon chills at the ballpark and the cost of it. So now on this, on your x-axis, you need to go ahead and take a look that these are gone by 2s. They're not gone by 1s like in problem number 1. And then the y value here is gone by 15ths. So we can actually start at 0 because that's where the line begins. And so the rise, that means if we try to go up 1 and over, it's never ever going to hit at an intersection. So what we need to do is we need to travel up this line until it crosses through an intersection, which is right here. An intersection means where it makes a T. All right, so now we can start at 0. To get to where that T is, we're going to have to go up 1 unit, which is 15, and go up another length, which is 30. So our rise is going to be 30. And it says, what is the run? Well, remember, these go by 2. So this will be 2, 4, and 6. All right, so then it says, well, what then is the rate of change? Well, that means 30 divided by 6 is 5. So this is how much it cost per lemon chill. So $5 per lemon chill. And then 2C says this function represents direct variation because the graph goes through the origin. Okay, let's go ahead and take a look at what we have on this next one. It says, problem 3 through 5, the graph is tracking the amount of money in a savings account. At what rate is money being added each week? All right, so let's just go ahead and take a look at this here. We've got, we're starting at 0, and notice that the x-axis goes by 1s and the y-axis goes by 50s. So at 0, it would be 100. So there's already $100 in there. And then week 1 it's halfway between 100 and 150, which would be 125. And then week 2 is 150. Week 3 is going to be 175. And week 4 is at 200. So on problem 3, it says, well, what is the rate? Okay. So what we're going to have to do is we're going to have to do the rise over the run. So per week, we can actually calculate, instead of doing rise over run, I think it'd be much easier. We can look to see. We've got 100 to 125. That's 25. Then we've got 125 to 150. That's another 25. 150, 175 is 25, and 175 is 200 is 25. So basically, we can calculate that by just looking at the table of values and see what it's increasing by. And since the week does go in sequential order from 0, 1, 2, 3, 4, then that would be another indication, be 25 divided by the difference of the weeks, 1. So 25 divided by 1 would give us 25. So what is the starting amount in the bank? Well, it's $100 because that's what it was at week 0. All right, let's take a look at problem 5. Problem 5 says, which equation would relate the total in the bank at any given number of weeks? So remember, your starting amount is 100, and then you're going to increase it by $25 per week. So that would be your answer B. All right, let's go ahead and take a look on the back side. We've got problems 6 through 8. The graph shows a price for renting a boat. If the boat was rented for 4 hours, what was the cost to the customer? So these are the number of hours, our x-axis, which is there, and our y-axis is here. So I'm going to go over to 4, go right over to 4, and go up to right there, and it's $100. So if the boat was rented for 4 hours, what was the cost to the customer? It was $100. All right, so then we have the next one. It says, what's the cost per hour? Well, that's kind of the slope. So what we can do, now if we go over 1 here and we go up, we see that it's going to be between 20 and 30. It looks like it's right in the middle of 20 and 30, but we don't quite know that. So remember what we did on the front page? We're going to start creeping up this line until it crosses through an intersection, which is right here. So what I'm going to do is I'm going to rise 50 and I'm going to run 2. So basically that's 50 divided by 2. $50 divided by 2 hours gives us $25 per 1 hour. So the cost per hour would be $25. All right, and then number 8 says, if in a different scenario where the total cost for renting the boat is represented by the function C of H, remember C of H is the same thing as just Y equals. So this is just the same thing as Y equals $25 per hour plus 60. What could the 60 represent in this situation? And what would happen to the graph? So the 60 could represent, what about some maintenance? Okay. What about gas? Okay, and just basic stuff like that. Okay, and so let's see what would happen. Let me go ahead and erase some of my markings on this graph, and let's see what would happen if we started at 60. So we're going to go and we're going to start at 60 here on the graph. And then we're still going to rise the 25 per hour. So we could go up 10, 25 per 1 hour. Okay. And then we could just keep going up that. So it would look like this. So it would just mean that it would be moved up, but it's not any steeper. because the slope is still the same. So the slope is not going to change. It's not going to angle any different. All you're doing is moving up the y-axis a little bit. All right, let's take a look at problems. I don't know what's going on with my, let's pause this. Come on now. Okay. We'll try to keep going here. I don't know. Something's kind of wonky with everything. All right, problem 9 through 14. The problem shows a relationship between the amount of water being drained from a large tank as a function of the number of hours that have passed. What number represents the y-intercept? So you need to remember that's your x and that's your y. So the y-intercept is 1,000. All right, then it says, what does it stand for in this problem? Well, that is the beginning amount. So beginning amount of water. Okay, and then number 11 says, how long does it take for the tank to empty? Well, as you can see, if it starts out at 1,000 and over a certain period of time, the number of gallons decreases until it gets to 20 hours. There, it's working now. So 20 hours. And 12 says, what would you call that point on the graph? Well, it hits the x-axis, so it's going to be the x-intercept. All right, and then we've got number 13 says, at what rate is water being pumped out of the tank? A couple things you could do here. You could go ahead, your rise, okay, here is your rise, and here is your run. So your rise is 1,000, your run is 20. Okay, so then what you could do is you could go 1,000 divided by 20. The zeros would cancel out, and 100 divided by 2 is 50. So this is 50 gallons per hour. All right, and then number 14 says, which function would describe this relationship? So let's think about it. You start at 1,000 and you're draining. Draining is going to be subtracting 50 gallons per hour. You're right. The answer is letter B. If I can get that. Okay. Maybe. There we go. All right. Thanks for joining us. Talk to you later. So long. Technology is not my friend tonight. I can't get my video to stop.